Hello, so today I'm looking at M3 International A-Level May 2016. This is question 6. I can see this is probably about energy and circular motion or something like that. So let's have a look. A smooth, solid hemisphere of radius 0.5 is fixed with its plane face on the horizontal floor. The plane face has center O, and the highest point of the surface of the hemisphere is A. A particle P has mass 0.2 kilos. The particle is projected horizontally with speed u from A and leaves the hemisphere at point B, where OB makes an angle of theta with OA. As shown in figure 1, point B is at a vertical distance of 0.1 below the level of A. So that will be this distance here. The speed of P at B is V. Show that V squared equals blah, blah, blah. Okay, so here I think this is testing me on energy, because I know kinetic energy is, the formula is half mv squared or half mu squared. So that's where I could get lots of v squareds and u squareds. So if I look at what kind of energy it has at the top it has kinetic energy, and because it's projected with a speed u. It also has some gravitational potential energy. And then as it moves around here, because the surface is smooth, there'll be no work done against friction. So then that energy will be conserved and will give me the energy that it has here. So here it will have kinetic energy at B plus the gravitational potential energy at B. Now, if I take that when it is at B, there is no gravitational potential energy, then this I can just ignore, and here the gravitational potential energy is the difference that I'd get from A to B. Okay, so the energy at the top will be kinetic energy half times the mass, which was 0.2, which is 1/5, times the initial speed. And here I get the mass, which was 0.2, times gravity, g, times by the difference in height. And they told me that that vertical height was 0.1, so that's 1/10. And that will equal the kinetic energy here, so I get half times the mass times the velocity squared, and this time all the speed squared, so the speed is v here. Okay, so I can see that I have a fifth everywhere, so I can divide through by that. I want to end up with something where v squared is on its own, so I need to multiply everything by 2. And so if I multiply this by 2, I get u squared. If I multiply this by 2, I can see in the expression that they just had a decimal, so I'll just type all of this into my calculator. So I'm going to have g 9.8 times 0.1 or times 1/10, and then I'm doubling it, and so I will end up with 1.96, and that will equal v squared as required. And this is conservation of energy. Okay, and so that will get you your first 3 marks. Okay, then in part B it says find the value of u. So in order to find the value of u, well, here I've got an equation with 2 unknowns, so therefore I'm going to need another equation with u in it somehow. So actually what I want to do is eliminate v squared, so I need another equation with v in it, or with v squared in it. Well, they told me what was happening here, and the only other important position they talked about was this position B. And they said that the particle leaves the hemisphere at B, and so that tells me that at that point the reaction force will be 0, and so therefore the only force acting on it will be the weight, which will be acting straight down. So I could use that, and as it's moving in a circle, I will have v squared in the expression for the acceleration, and then that will give me another equation with v squared in it that I can then combine with this to eliminate v squared. So if I look at the forces that are acting on the particle, so when the particle is in this position, this is theta, then I have the mass will act straight down. The mass was 1/5, so I have g over 5 is the weight. Just in any position I would have r acting perpendicular to the surface of the sphere, and because this is moving in a circle, then I have the acceleration towards the centre. In any circular motion question, for the acceleration you can use r omega squared or v squared over r, and in this case this is going to be most useful because there's no mention of omega, there's no talk about how long it takes to do a complete revolution and things like that, so this should be the one that I'm using. Now I know the radius of the circle is this, which is 0.5, so a half, so the acceleration will be v squared, if v is the velocity at this moment, over the radius, which will be divided by half, so in other words multiplied by 2. Okay, so if I do Newton's second law towards the centre of the circle at this point, then I get here, using alternate angles, this is theta, so g over 5 multiplied by cos theta minus r equals the mass, which was 1/5, times by the acceleration, which was 2v squared. But at B, I know that r is 0, because that's where the particle leaves the surface. So therefore I get that g over 5 cos theta. How do I know what theta is? No, I don't. Okay, so I'll just leave that as cos theta. Equals 1/5 to v squared. So getting rid of these by multiplying both sides by 5, I can now divide both sides by 2 and I get v squared in terms of cos theta. Okay, so now I can put that together with the other expression that I had for v squared, and I can, so I will end up with u squared plus 1.96 equals this thing. So there I have, I might as well start ending up with decimals here. So I've got 9.8 divided by 2, which is 4.9. So I have 4.9 cos theta. So in order to calculate what u squared is, then I need theta. So they must have given me enough information somehow. So what did they tell me about the length? They told me that is 0.5. This is theta here, and then they told me this distance here is 0.1. And this distance here will be 0.5. So therefore this bit from here to here will be 0.4. Okay, so I can work out theta, cos theta, will be the adjacent over the hypotenuse, so 4/5. So cos theta is 0.4 over 0.5, which is equivalent to 4/5. Okay, so now I can put that 4/5 into here. So I get that u is going to be 4.9 times 4/5 minus 1.96 square rooted. So if I just stick all of that in my calculator, so I've got 4.9 times 0.8 minus 1.96. That makes 49 over 25, which will square root to something quite nice, like 7/5. So you can leave it as 7/5 or change it into a decimal if you prefer. That would be 1.4. Okay, and so for that part of the question you get another 4 marks. Then in the last bit of the question, they ask you, they say the particle first strikes the floor at point C, find the length of OC. So O was this point here, and so the particle will move to B, leave the surface at B, and then kind of move freely under gravity until it hits some point over here, C. And this is worth 7 marks. So how far will it move? Well, I know that it's going to move this distance first of all, and using this right angle triangle, this was theta, this was 0.4, this was 0.5, and so this distance is going to be 0.3 using this is like a mini version of the 3, 4, 5 triangle. So OC is going to equal 0.3 plus whatever horizontal distance the particle moves from B to when it actually arrives here. So I know what U squared is, therefore I actually know what V squared is now. So I know what the leaving speed is, which will essentially be the initial speed of this section of motion. So U was 1.4, so if I just work out V squared to begin with, so V squared is 1.4 squared plus 1.96, so popping all of that in my calculator, I get 1.4 squared plus 1.96 gives me this. So V squared is 3.92. And I know that at that moment the particle because now there are several ways to do this part of the question. So basically, because it's moving freely under gravity, you could see, you know, in this direction the velocity doesn't change. In this direction there is an acceleration of g towards the ground. So you can use energy to help you, or use suvat to help you. Now I'm going to use energy. So at B, there's this kinetic energy, and it's also got some gravitational potential energy. And I know that that is going to equal the kinetic energy at this point C. And if I take that once it's hit the ground, there is no gravitational potential energy once it's over here. Okay, so the kinetic energy at B is going to be half times the mass times this, which is V squared, plus mgh, so 1/5 times g times the height, and I know at B the height was 0.4, which is 2/5, and that will equal the kinetic energy at C, half times the mass times, I can't call this V squared because I've already used V, so call this, can't use X, let's call it W squared. Okay, I've got fifths all over the place, so I could multiply through by 5. And let's work out what this number actually is. So I've got 3.92 divided by 2 plus 9.8 times 0.4, and then I'm going to double it so that I get what W squared is. So W squared is 11.76. Okay. Now, so that is the velocity with which it hits the ground, but I need to remember that or when I square root that, I'll get the velocity with which it hits the ground. So that is basically in this direction. And what I know is that in this direction the velocity hasn't changed at all compared to the initial velocity that it had at B. So when it was at B, I know that it was moving with V, and theta was down here. So theta is there, so that's not theta, so this angle here is theta. So I know that V cos theta, this part of the velocity, is unchanged, and so that's here. So W is here and V cos theta is here. So if I focus on what I actually want, what I really want is x in this direction. So what I define to be x up here. Okay, so that is the distance horizontally that it travels from B to C. So this distance here. So if I look at in this direction, suvat what's happening, then the displacement is x. The initial velocity, so that's the initial velocity at B, is v cos theta. So I worked out v squared is this. So I need to do this 3.92 square rooted, and that then gets multiplied by cos theta, and cos theta was 4/5, so times 0.8, and that gives me this yucky thing. I'm going to stick that in my memory A's. It's quite a horrible number. So, but this was basically v cos theta, but it's a value that I have. Okay, I know the acceleration is 0 in this direction if it's moving freely under gravity. So I need one more thing. So I could use the final speed. Well, I know the final speed is the same, and I know what W is, but here I'm missing a value, so I don't have enough information. But if I look vertically at what's happened, then I know that the distance is 0.4. I know that the initial velocity is v sine theta, so essentially I know that as well. I know that the acceleration is negative g, as I've defined, oh no, sorry, positive g, as I've defined down to be positive. And then I need one more thing. So perhaps if I work out t here, or v here, then if I've got the final velocity, that tells me what this side of this triangle is. So then at that point I know, or I can get this using this triangle, sorry, because I know what v cos theta is, I know what w is, and so then I can work out this final velocity using this triangle, or using these values here. Why would I need that? Well, because then I could work out what t is, and then I could pop the value of t back into here in order to work out what x is. Okay, so the final velocity here is going to be w squared minus this squared, so v squared was 3.92 times by 4/5 squared, and then square root that answer, and that will give me what v is. And then I could use even v equals u plus at is the simplest equation I can use, so that I can work out the time. So to get that time, I do the final velocity, which is this thing. The initial velocity is v sine theta, so that is the square root of 3.92 times by 3/5 plus g times t. Okay, so then I can just rearrange this to get what t is. So I will do the square root of 11.76 minus 3.92 times 0.4 squared. And that gives me this value here, minus root 3.92 multiplied by 3/5, and then divided by g, and that gives me the value of t. Okay, so you should get that t is 0.219. I'll save that in the memory. I'll save that in B. Okay, and then now that I know the value of t here, then I can work out s. So s is ut plus half a t squared. Well, because the acceleration is 0, all of this bit is going to disappear. So I get that x is that value of v cos theta, which if you remember I saved into the memory a, times by the value of t, which is this, which I saved into the memory as b. So x is basically for me a times b. So I've got a, b, and that gives me 0.347. So the distance that they wanted was OC, which was 0.3 plus that value of x. So now I do OC is 0.3 plus this, and so I get 0.65 or 0.647. Okay, so that part of the question is worth 8 marks, I think. 7 marks. So altogether you've got 7 plus 4 plus 3, so you have 11, 12, 13, 14 marks altogether. Okay, I hope you found that solution helpful. Do click like if you liked it, and good luck with your studies.